Hey guys, this is unit rate as slope part 2. I started this from the other clip just because the other clip was way too long. So let's go ahead and get started on this. So Adam and Alan ran against each other, one another, in the nearby woods. I picked those names because those are my two boys. Anyways, they both ran a total of 1,760 yards each. Apparently I put an extra 0 there on accident. Find the unit rate of each boy and determine who ran faster. So we're given some information here. Okay, let me see if I can zoom in just a little bit. Just that glaring is bothering me, to be honest with you. Okay, that's a little bit better now. So we can see the distance: 400 yards, 80 seconds, 600 yards, 120 seconds, so on and so on. Obviously, we don't have the tail end of 1760 here, right? But we had it here. Obviously, one of the reasons why is because if I had 1760 here and the time, you just look at the time and go, okay, I know who ran faster. So in an effort to conceal some of that data, we just pretended like, well, you could only get his pace at these points for Adam, and at these points, Alan. So I made it a little bit more difficult to figure out. Just that it forces you to find the unit rate and then just compare the unit rate with one another. So these both are proportional. Okay, we're going to be talking about non-proportional equations. Right, we'll talk about that later. But right now, these are all proportional. We're going to start at 0. Okay, basically stating that at a specific time, or at the beginning of the race, no time has occurred, right? I mean, no time has elapsed or lapsed over, right? So this is 0. There's no time. They're just standing still, right? They haven't ran yet. They haven't started yet. And then time would obviously be down here, be linear. It would go in this direction. And then distance would be on the y graph. I'm sorry, on the y-axis. And distance would go in this direction. It would gain, right? You would never lose distance unless it's distance from a particular point. Okay, so that you can come back down on, but we're not doing that here. Now we're not graphing these. We're just going to be looking. Just wanted to show you basically what the graph would basically look like, or time and distance. We're just going to look about how to get the equation from both of these. The big thing is just as long as you know that y equals kx. Okay, that's the nexus of what equations start out as. K is the constant. K is your unit rate. This is the unit rate, also known as slope. Okay, you're going to see that down the road as m. A lot of times, the slope-intercept rate is y equals mx plus b. Okay, I know it's all letters and I get that, and it's a little frustrating, but trust me when I say this, at this k is the m. It is the slope. It is the rate, and that's what we're looking for. We're not using this right now. This is mainly for, it can be for proportional equations, especially if b is 0, if there is no y-intercept. But mainly this is used for non-proportional relationships or equations, linear equations that don't start at the origin. We'll talk about that later. Okay, so we're just looking for k. We've got the x, we've got the y. Okay, this is the y, this is the x, but we don't have the k. We got to figure out what the k is. So in an effort to do that, you can just take any ordered pair. I usually pick the smallest one, just because it makes life a little bit easier. So you plug that in to what you know to find out what you don't know. So you plug in the 400. So for Adam, I'm going to write down 400 where y is. For x, I'm going to write down 80. K, I don't know, so I just leave that alone. So k times 80 equals 400. And the same thing here. So y is 440. X is 110. K, we don't know. We set that equal to each other. And then you just basically do a one-step equation. You divide both sides by the number that you're multiplying to find out what k is. So when we do that, obviously this is going to cancel out because that's the goal. The goal was to get rid of that, right? So we want to find out what k equals to. So the equation for Adam is y equals 5x. And for Alan, it's y equals 4x. So the unit rate is 5 what? Well, it's 5 yards per second. So if Adam is running 5 yards per second and Alan is running 4 yards per second, who's running faster? Obviously, it's going to be Adam, because he runs 1 yard faster per second than Alan does. And that's it. That's how you solve that. Hopefully that makes sense. Apologies if I went too fast. Let me know. I would say in the comments, but I think the comments are just so good in this video. So just make sure I know in class. Send me an email. You know how to reach me. I'd be happy to make more. Okay. God bless, guys. Take it easy, and talk to you later. Bye bye.